Okay, so let's have a look at the workflow where we use Investigator to create a classification that we generate from a seismic attribute crossplot. So the first thing is to build the seismic attribute crossplot to build the investigation. So here I have opened up a Petrel 3D window, and in that Petrel 3D window, I am displaying the attributes that I want to add to my crossplot. So here in this example, I'm crossplotting near versus far. So I'm displaying an inline from a near stack and a line from a far stack in the 3D window. We can add more attributes if we want, but I'm just doing this relatively simple. So to build the investigation, I'll right click on one of the surveys here and go in and add a new blueback seismic spatial selection. That's the probe that shows up here. It covers the entire 3D survey. So we want to crop that down to a very small area. If we include all the points from the 3D survey in the investigation, we will crash Petrel. So to start out with, we will use a very small area using this cube here. So whenever we have the spatial selector that we just inserted sits in a spatial selector folder. When that is active and we go to the pointer mode, we can then grab these widgets here and then crop this down to a relatively small area. We usually say something in the size of about 3 by 3 kilometers and then 2 to 300 milliseconds. That's usually what we start out with. So I'm locating this over what I know is my reservoir interval, like this. And then we can right click on this spatial selector icon here and say create blueback investigation. Here it prompts us for a name, so I'll just call that near versus far, or N versus F, like this. It is now building the investigation. It's adding the near attribute and the far attribute and the X, Y, and time coordinates. So here you can see near, far, X, Y, and time. Since this is 3D seismic, the tool knows that we potentially can add millions and millions of points, so it's applying a heavy decimation. But since we are limiting the investigation to that certain spatial selector, we can then go down to, for example, every second inline and crossline. You can see the number here now turning red, telling us that now we are adding a lot of points, but this will still work. So I click, I say OK, and now that is saved here in a designated investigations folder. So I can right click and say open up this investigation in a 2D crossplot. And here we will get the 2D crossplot and we'll just split the screen or tile the windows here. I was hoping, yeah, like this. So here you can see it's adding the near as the X, the far as the Y. If we added more attributes, we could easily determine what data we want on the different axes. So for example, we could say time versus near, which doesn't really make sense. And then we just go back to far versus near. And then we can, for example, color by the far. The color scale here is the color scale that has been applied on the Petrel seismic template. We can also, since we added X, Y, and time variables to the investigation, we can display that in the 3D window. So that is now the investigation being displayed. And then we can also determine the coloring in the 3D window. So when the Petrel window here is active, as it is now, we can open up the investigation panel, go to Petrel window style, and again, color by far. So now the points here are being colored by the far attribute. And then we can apply a filter here in the crossplot window that also will be applied to these points over here. So the way that I zoom in and out here is using my mouse wheel and then using the third mouse wheel button here to pan. To add a filter, we can go to this drop down here. This is the filter entry button. Hit that one. go to filters, and you can see we've got different filtering options. I like the polygon filter here. So let's try and draw a filter to grab some of these high far versus near points. And now we've applied the filter, so it's not been applied over here. That's because we haven't linked the windows. So the way that we link this crossport window to this 3D window is this link visuals button here. So now you can see that the filter has now been applied, and we can go in and say play around a little bit with this filter. Say I want a little bit more information. That's being updated on the fly, something like this. So that is just doing that filtering inside of the probe here. So what if we wanted to apply that filter and give us that particular feature, that particular featured filter for the entire lateral area or the entire 3D cube? We will go ahead and run what we call a discrete classification workflow. So, and by the way, at any time you can go and say save as point set. Then these filtered points inside of the probe here will be saved as a standard Petrel point set if that is of any use with the different attributes sampled here as a point set. But we want this for the entire cube. So then we will need to go into the investigation and define a template for that discrete classification. So we open up the investigation again. We then go to classification group. This is where we define the discrete template. You can see this is empty. So we will add a new discrete template. We can use one of the existing ones from Standard Petrel, or we can build our own. So here I'll be adding two classes. We'll just be adding one for the feature and one for the background. So the first one here, we'll call that F for feature, and we'll pick like a bright color. We'll pick red. And then the second here we'll call B for background and give that kind of a dim color, maybe this light green, like this. So this is the classification. So we'll be assigning the red to the filtered feature and then the B to the background. And then we have, that's only the template. Now we need to define the classes from this 3D plot. So we would like one class to be defined by this. So here again, we go to the filter entry, but instead of picking a filter, we will pick a classification region. Again, I like the polygon method where we can go in and select more or less that same filter here. That is one. The way that you finalize this is double clicking, and then we'll select a second region for the background. Again, I'll use the polygon, and here you can see I'm picking that with an overlap. The polygon that I picked the first takes priority. So now we have those two regions. We'll untoggle the filter, and now we need to assign the discrete classes that we defined in the template. So I'll right click here on that polygon and go down to assign classification. This is my feature. And then we need to assign the background class to this polygon here. This is background. And now we can color points by these two classifications like this. So you can see that first polygon takes precedence over the second. And we can also go in and color these points by these new classified features. If we go to the Petrel window, now we can also go and color, and we can now see that we have that feature and then the background. And I think, can we actually apply that same kind of filtering? Yes, we can. Okay, so now we would like to apply this filtering to the entire 3D cube. So here we'll make use of a tool called, so here from the Marina menu, that is accessible when you are in the Petrel home button. From this Marina menu, I'll select the Blueback Investigator entry, and here we have a few tools that comes with the Investigator. So we'll select the Equation Transformer. That's a tool that allows us to apply any transformations that we've defined with an investigation to apply that transformation to a separate data set. So here we'll go in and select that investigation, the near versus far investigation. It only has that one transformation, the classification that we just defined here. Then we will define the data set that we want to apply this to. So here, insert a new data set, select geometry, so it's the same data set. So here you select the attribute as the data set, and it immediately automatically picks the near versus the far, which is used to run this discrete classification. And then before we hit apply, we need to untoggle this, because if we don't untoggle, it will just calculate this seismic cube inside of this spatial probe. So we'll untoggle, and then we'll give this a name, seismic near versus far feature, for example. Hit OK. And now the tool will start to run this classification. And this, depending on the seismic, the size of the cube, this will take a little while. This is the demo data set, so it doesn't take more than 3 to 4 minutes. But while this status bar here is running, I'll just pause the recording. Okay, so the tool is done calculating, and then we can scroll up here to see that we have now added a new seismic cube with the name seismic near versus far feature. We can toggle a line on, and then you can see we have this highlighted feature, this particular highlighted feature highlighted. So let's untoggle the investigation here. Then we have highlighted that feature for the entire cube. Of course, anywhere else in the cube where this selection here is valid, this crossplot, like up here, that has also been included in the seismic cube.